OTPs and PSAs. Some of you will know what I'm talking about, some of you won't. A PSA is a pre-startup activity. An OTP is an operational test procedure. PSAs, pre-startup activities, cover a multitude of sins. If you need to put catalyst into a tower, that's a PSA. It's required before you can start up. If you want to fill oil into a compressor, it's a PSA. You need oil because the compressor won't run if it's got no oil in the bearings. Even a small pump, it's a PSA. Needs a small procedure. It might be half a page, it might be 100 pages. There are small ones, there are big ones. Also, as part of the literature that comes with the course, you will find an example of one, which will give you the layout. It won't tell you how to do what, but it will show you the sequence that you need. It will show you the index that you need to follow so that you get it right. And always when you're writing these things, make sure you're specific. If you're going to write about Tower 101A, make sure that every single time you mention the tower, you write 101A. Don't just write 101, or you'll find somebody doing something on 101B and 101C, and that might be dangerous. You don't want it happening yet. Be specific and make sure that every time you mention the equipment or the item, you get the right one. OTPs, operational test procedures. This is when you can run, for example, a compressor without using gas. You can use nitrogen instead, which is safe. So you can take away a lot of the risk. You can run pumps with water instead of using oil. Safe, not messy if there's a leak. You can use another medium if you want to, as long as it's compatible. Another one of the OTPs is the test runs. Every single pump, for example, will need to have a test run, an unloaded test run. You need to make sure that the motor is good before you connect the pump to it. Maybe it won't be big enough to drive the pump. So normally you do a rotation test first, which shows you that the pump, or that the motor rather, is running the right way, and you're getting the correct voltage on the correct polarity. And then you will do a 4-hour, usually, unloaded run, during which you will record temperatures, vibrations, make sure that the motor performs well, doesn't get too hot, and then you can couple the pump and run the pump. All sorts of OTPs. Again, part of the course notes will have an index and a pro forma that will show you how to write an OTP. You need to write every one differently for every different type. Some will be the same. If you're using, for example, 6 pumps, then you can write one and just change the letters A, B, C, D, E, F, G for the pumps. Not a problem. But we will give you some examples.
Okay, great. Thank you very much.
As a lead on to that, you will need to use specialized companies. You will need, for example, if you're going to run an H2S plant, sour gas plant, you need to have it all tested by nitrogen helium. An audible leak, a leak that you can hear, is 30,000 standard cubic feet a year, which is quite noisy, but it's not much. 30,000 standard cubic feet a year, it's less than 1,000 standard cubic feet a week. But if you're doing H2S, the leak rate accepted in the North Sea is around 15 standard cubic feet a year for a flange and 10 for a valve, which is almost non-existent. You couldn't possibly hear or feel or see with bubbles or anything a leak like that. So what you do is you use nitrogen helium. You put in a trace of helium gas with your nitrogen test medium, and then there are specialized devices that will sniff around the joints, the flanges, anywhere that they might have a leak, and it will tell you, is there any helium coming out? Because if there's helium coming out, then the gas will come out. That's one specialized contractor. Another one, well, there are several again of companies. All these things have many companies. You need to find one that is acceptable to your client or to your company and get in touch with them. You have some companies that will give you a complete service on your piping. So they will receive your piping into the piping yard. They will clean it. They will then cap both ends to keep dust and dirt out. When it's ready to go up, they will help to make sure it's transported in a clean state. When it's all installed, they will come along. They will test it, either by nitrogen, helium, or just with water or whatever medium you want to use. Having done that, they will then prepare you a register for your flanges. Every single flange, everywhere that something is bolted to something else, will have a register, will be on the line, and it will tell you exactly what bolts are used, what strength they are, what material they are, what the threads are. It will tell you what the nuts are. It will tell you what the gasket is. It will tell you the service. Everything about that particular flange will be on that register. One flange, one line. And when you've got a big plant with maybe 4 different trains, you are talking hundreds of thousands of joints. But they're very, very important. Another specialized contractor you will use are the heavy lifting people. Again, heavy lifting is something that you're bound to be involved in as a commissioning engineer. There are various rules and regulations. You need to be aware of them. You need to be aware that you cannot lift heavy lift over live lines. What happens if something breaks and the lift crashes down and breaks the line open? Things like this. You have to put barriers around for a certain distance in case something goes wrong. And never ever think that nothing will go wrong. It does. Murphy's Law will tell you it will go wrong if it can. You have to be prepared that either, well, I won't say that it won't go wrong because I've just said it will, but you must make sure that if it does go wrong, it has the least impact on your site and your people. Very, very important. Be on your guard. Always assume that it will go wrong and try and make sure that you've covered every possibility.
Maybe one hint. When I worked in Saudi Arabia at a project, we had a specialized company for steam blowing. So they came with the complete equipment, everything.
Yes,
maybe you have as well some experience.
Steam blowing is another one that's it's a dangerous job. There are so many things that can go wrong. There's so much energy produced by steam. And you have specialized companies. One of the most important things they do, if you have a plant that has steam in it, you have boilers. Boilers have to be cleaned. When they come from the manufacturer, they're dirty. There's all sorts of grease and stuff inside where they've been preserved. All that grease has to be cleaned off with acid. Then you have to run a pacifying material through to counteract the acid, otherwise you'll end up burning holes in all your tubes. Then you have to flush everything out, and then they have to be inspected that everything is clean. Then you can box it up. Then you can use the steam to do your blowing. You can also, if it's only small amounts of blowing you're doing at a time, bring in a temporary boiler. This can be connected just to do a steam blow, but it's not connected for main service. Again, specialized companies. If your company doesn't have somebody that they know that will do this, look on the web. You can find anything on the web. But make sure that they're reputable companies. Make sure you go through your senior management so that they're comfortable with what you're doing. Don't just get something that, Fred Bloggs and Co. Doesn't work. Can I tell a funny?
Yeah, sure. The people will love to hear it.
One example of this, we mentioned earlier on in the course about fires and things and Red Adair. Well, there was another company that was formed called Green Adair. And this was an Irish company. And they had an old surplus to requirement military fire engine called a Green Goddess, mainly because they were painted green. And he had this thing and he was going to advertise himself to put out oil field fires. So one day a company called him up and said, what's your fee for putting out a fire? Oh, he said, maybe $50,000. Oh, but Red Adair wants millions. Ah, well, yeah, but that's Red Adair. I'm Green Adair. Oh, okay. When can you come? Well, next week. Okay. So you come next week and put the fire out, please. Okay. So the guy turns up at the site where the oil field, where the well is burning. And he's got his Green Goddess fire engine. And he's got his fireproof suit on. And they said, well, there's the well. Put it out. Okay. So he starts up the fire engine. And he drives hell for leather for the fire. And the fire engine disappeared straight into the middle of the fire. And there's a huge bang, and the fire was out. And the fire engine came back, and the guy gets out, and he's singed eyebrows and smuts on his face and everything. And the man said, my goodness, that was magic, he said. How did you do that? He said, well, the same way Red Adair does with a stick of dynamite, but, a little bit quicker. And I said, well, yeah, cheaper. What are you going to do with the $50,000? Well, he said, the first thing I'm going to do is buy some brakes for that fire engine. Yeah.
Okay.
It's nice to have a laugh, but there is always a serious side to it. As I've said, be careful. He wasn't careful. He didn't check his brakes before he went for the fire. He should have done. Then he wouldn't have gone into the middle of it.